First of all, good afternoon, my dear doctors. Last class we have studied about the absorption, that is pharmacokinetics. There I have left it with the last topic. I said it is very important. So it is the pH. How a pH changes the absorption, whether it increases or decreases. Whatever the food or whatever the drug which we are taking should get absorbed. Then only when it goes to blood, it shows its pharmacodynamic action. That is what we need. We need a pharmacological action. So pH is very important. There is a formula for pH. pH is equal to pKa plus log of ionized drug divided by unionized drug. So this formula and the details of that will be very difficult to understand. I will make it very simple. Instead of going how this formula is derived and how we are getting it, just a golden rule I will tell you. So this much I think it will be enough. Golden rule. What this golden rule says, it says of two things. That is basically what we have to know as a doctor. If we are taking a drug, that drug should be in which form to show its pharmacological action. That is what our aim is. I'll just repeat it once again. If I am fast, please let me know. If you are not understanding, just let me know. If you are fully understanding, with your faces only I can understand. So please tell me the truth, so that I can make myself to make you comfortable. Okay? See what the golden rule says. If the drug is ionized, what do you mean by ionized? Drug converted into a charged particle one. Okay? So if it is ionized, then it goes for excretion. No action. There is no pharmacological action. If the drug is ionized, that is what the golden rule says. If it is ionized, if it is unionized, then we have action. How we are getting action? Because the drug is in unionized form. So that is action means here we are talking about absorption. So we will write it absorption. It will be more better. Absorption. If the drug is going into blood, if it is going into blood, then only it will show its action. If the drug is not going into blood, it is going directly out. That is ionized form. This is the first golden principle. That is the golden rule. The second golden rule is, here we have to give more attention. If it is acidic drug. Here I mean acidic means it is a weak acid or weak base. Okay, the drug should be in a weak form. It should not be strong. If it is strong acid, strong base, directly excretion. So if it is acidic drug, the drug is acidic. Then if it is unionized, then absorption. Right? Where it is getting absorbed? In acidic medium. That means in stomach itself. If the drug is acidic and if it is in unionized form, then it gets absorbed. When it gets absorbed, it is in acidic medium. All these things happens in stomach. That is in acidic medium. If the drug is basic, if it is a weak basic drug, If it is a weak basic drug, then it is ionized, so there is no absorption. It gets excretion. It gets excretion in basic. Uh, Let me make it as acidic. So the next line I'll go. If it is acidic drug, gets ionized, gets excreted in where in acidic in basic medium. Here it is basic medium in the intestine. Example: if the drug is acidic, where it will get absorbed? It will get absorbed in stomach. If it is in the intestine, then it will get ionized and it will excreted out. Is this clear? Let me repeat again. So slowly we will go. If the drug is acidic, then it will absorb in its stomach. Okay. When it is getting absorbed, the drug should be unionized, then only absorption takes place and it will absorb from stomach. If the acidic drug gets ionized, excreted out, when this will happen? If it is basic medium. Acidic medium. Acidic likes acidic medium. Acidic drug likes acidic medium. Likewise, opposite of this. If it is a basic drug, here only I will write. If it is a basic drug, if it is a basic drug, then if it is a basic drug, then it is ionized, right? Gets absorption in where? Which medium? Basic medium, because acidic like acidic, basic like basic. So this basic means basic medium. Okay, this point is clear. Just I am changing here only so that you will understand. If it is basic drug and if it is unionized, then it will excrete out in acidic medium. Very good. Acidic medium. See, after getting all the derivation, we will understand this. So I am making you to understand this simple way with golden rule of 1 and 2 so that it is very very easy. First one is very easy. Ionized absorption. Ionized excretion, unionized absorption. That's why we give in a salt form. Then same thing, if it is acidic medium, in acidic medium it gets absorbed. Absorption, it should be unionized. And if it is in basic medium, it should be unionized, then absorption in basic medium. See, I got it. Always absorption only in unionized form. This is a golden rule. Now, so after absorption, there will be distribution, there will be metabolism, changing the polarity of the drug. What is polarity? The structure will get changed. If it is lipid soluble, the drug will be water soluble, so that it can be easily excreted out. Now, then excretion. For excretion, I'll just tell you different ways with different organs where the drug is excreted out. Very simple way. Just select. So how it is excreted out with different organs, and what are the things which make it to excrete out? Excretion. I complete this topic and then we'll go to next new topic. That is what our today's class is. But to make it before, I'll write it as kidneys. Kidneys are the major part of excretion. Okay. Then we have what? Liver. We have skin. Very good. And then we have lungs. Yes. And saliva. Right? What things are getting excreted via which means? That we will see in a brief way. As a doctor, we should know the excretion of whatever the drugs or whatever the things physiologically, what after getting energy, the waste should be eliminated out. So by lungs, mainly which part, which is the waste product which is excreted through kidneys? Urine. Yes, urine contains what? Mainly for what part we excrete it out? It is main component is urea. Okay, around 25 to 30 grams of urea per day we are excreting out in 1 to 1.5 liters of urine. Okay, urea is the major part here. How urea is formed? Anyone? Do we know physiologically how urea is formed? Yes. It's formed in liver. Very good. So what happens in liver? Do we know glyconeogenesis? What is neo here? The word neo means usually how we get glucose. Glucose is the energy source, right? How we get glucose? Breakdown of carbohydrates, right? Carbohydrates breakdown gives. That is what the digestion is. What is the aim of digestion? Digestive system. Very good. From complex food material to make it very simple form. Complex is starch. The simple is glucose. Broken down to make a simple particles. So that is glucose. Now, if it is not from carbohydrate, if it is from proteins, breakdown of proteins, if we are on starvation, we are not having enough glycogen, whatever is stored, then how we will get the glucose? That is from proteins. How? From proteins or from lipids also we will get the glucose. That is called the neogenesis. Glycogenesis is very simple. Breakdown of carbohydrates to give glucose. Glyconeogenesis means other than the carbohydrate, if you are getting the glucose. Understand this point? Okay. Now, like example, I will write the formula here. NH2CHCOOHR. Now this is a amino acid. Just basic structure of amino acid. What is R? R is a any of carbohydrate hydrocarbon group which makes particular amino acid. There are many amino acids. Glycine, albumin, all these are different amino acids. So this is because of R we are writing to make it different amino acids. So what is happening here? There is a deamination takes place. There is a reaction where amino groups comes out. NH2 group comes out. If the NH2 group comes out, and this will form what? Glucose. That is glyconeogenesis. So we are getting glucose. Now what is this then? It's a waste product for us. It has to be eliminated out. If we eliminate out this, that means it will form what? NH3. Because H is easily available, it will convert into what? Ammonia. NH3 is ammonia. So urolithic we say. All mammals are urolithic. Means what we are doing, this ammonia has to be excreted out. But ammonia is very toxic. If our body forms ammonia, this is very very toxic and it needs lot of water. To expel the daily ammonia, we may need 50 liters of water. Our body cannot do that. We have reserved water. That much water we cannot use it for urination. So what our body does in liver, this urea will convert ammonia will convert it into urea. It enters into ornithine cycle. That is called urea cycle. So in urea cycle, this ammonia is converted into urea. Urea is less toxic. Less toxic. Less toxic means what? It is not that much toxic as ammonia. So this urea, which now we can expel out with the water to make it dilute, and urine is formed. Urine is formed in animal, in mammals, so that this urea is excreted out through urine. So how urea is formed? Why we are excreting it? Because this is a waste product. It should not circulate in the blood. It has to be eliminated. Once it goes to kidneys, the kidneys traps the urea. There are urine formation, three steps. One is filtration, another is reabsorption, another is secretion. Whatever the filtrate, that is around 180 liters in a day, filtrate will form in glomerular filtration. So blood capillaries gets, because from the pores, that is called fenestrate. From there the blood gets filtered off. That means all urea gets into Bowman's capsule. From there glucophenolate. Again reabsorption. If it is more, glucose also comes out. So all things around 80% gets reabsorbed, and then from there secretion takes place. Some blood from in the blood, instead of filtration, it passes to another peritubular capillaries. So there hydrogen ions, like example potassium, that also comes back into the nephron, that is to tubules, that is secretion. Reabsorption is going back to blood, secretion is coming from blood to again tubules. So urea is 100% gets into filtrate, and then there is no reabsorption, there is no secretion, it is eliminated out. So this is how the kidneys removes, that is in the form of urine, especially the urea. That is what the main part of excretion. If we consider kidneys, then it is urea. Okay. Next is liver. May I fast? Are you easily understanding? Yes. So please let me know if you are not understanding. I can repeat it 100 times. I don't have problem. I'm a teacher. Basically, a teacher is one who has the quality of having patience to make the student, until unless you don't understand, we will not go forward. Okay? Right. अगर बीच में उर्दू भी चाहिए, I'll try to make it. No problem. It is very compulsory today. Compulsory. Okay. There are many students from the department of this. Now, how many of you? Yeah. How many of you who cannot understand my English 100%? Is there anyone? 85%. So this statistics is needed, because 15% I will add Urdu, so that it will be 100%. Will it be okay? अब हम लिवर में आ जाएंगे. राठी सर, स्लीपिंग. बुलाइए राठी सर को, उर्दू में बोलता हूँ. सर डायग्राम के साथ में थोड़ा सा बताइए. आपके बगैर नहीं होता. आगे आइए. थोड़ा दीजिए. फिर तो सब बैठेंगे. हम यहाँ बैठेंगे. आ जाइए बेटे, आप आगे आ जाइए. यस, मैं ऑडिबल नो? देयर इज नो प्रॉब्लम. अभी लिवर में क्या होता है बताना. हमारी बॉडी बहुत सी चीजों को एक्सक्रीट कर रही है, निकाल रही है, फेंक रही है, बाहर निकाल रही है. ये इसलिए निकाल रही है क्योंकि वो हमारे लिए वेस्ट है. वो कैसे निकाल रही है, दैट इज व्हाट वी आर गोइंग टू सी फर्स्ट, देन वी विल गो विद द फार्माकोलॉजी. तो यहाँ पर जो है लिवर क्या कर रहा है. लिवर is a main excretory organ. Why we say main excretory organ? Liver forms bile. What is bile? It's an important essential part for digestion, right? So this bile contains bile salts, bile pigments, and cholesterol. Mainly There are many salts and other things, but it does not have any enzymes. This is a very important point. As a doctor, if anyone asks you what bile contains, it does not contain any enzymes. It has no enzymatic action. What is this bile salts? This is very important. Bile salts have a very important role. As in my last class, I said the bigger globule has less surface area. The smaller, if you break it down into many smaller pieces, the surface area increases.
Yes.
So, what bile salts will do, it will mainly cholesterol, it will break down into smaller pieces so that it is called emulsification of fat. Emulsification of fat is done by bile salts. Very important part. So that those fat is available in the small intestine, where it is, with the enzymatic action, it will convert it into fatty acid. Smaller particles. That is the minimum. सबसे आखिरी चीज जो है वो होती है फैटी एसिड. लिपिड से फैटी एसिड. ऑयल ले लिए, बहुत मजेदार चीज थी, बचियां बहुत अच्छे थे, खा लिए, तो अब ऑयल निकलेगा कैसे? वो निकलेगा भाई फर्स्ट प्रोसेस एज बाइल सॉल्ट्स. वो हमारे लिए बहुत इंपॉर्टेंट चीज है. ओके, नाउ वी कम टू दिस बाइल पिगमेंट्स. वेरी बैड थिंग फॉर आवर बॉडी. बाइल पिगमेंट्स मींस वेस्ट प्रोडक्ट. इसको निकालो, इसको फेंको. बट बाइल का कॉन्स्टिट्यूएंट है, इसको फेंकना जरूरी है. Who will do this job? That is, liver will do this job. That is why it is an excretory organ. क्या करता है ये? और what is this bile pigment? I am telling it is not good for our body. अब good नहीं है तो फिर आया क्यों? कहाँ से आया? ये हम सोचेंगे. अब इसको जानकारी हासिल कर लेंगे कि क्या हो रहा है. Yes, I'll write it here itself. We have an organ called spleen. Do you know what is the spleen and what is its function? The other name of spleen is called graveyard. You know, Kabristan. Smashanam. Graveyard for RBCs. That is what the spleen is. Why we say graveyard for RBC? Why only spleen? Why not other organ? Because blood is going everywhere. It gets struck in RBC. RBCs are getting struck here and they will die. So that is why we say spleen is a graveyard of RBC. Immune system is very important. Spleen as the major part of lymphatic system. Okay. Now, what this will do, I'll tell you, because I'm going somewhere other than my subject. So will it be okay? Okay. See, what this will do, RBC cells. If we talk about blood, it is mainly RBC because it is in millions cubic millimeter. It is around 5.5 or more, right? So RBCs has to form every day and it has to again every day. So the lifespan is 120 days. How RBC knows that when it has born with a calendar and it is dying exactly on 120 days? No. Then how? In what way we know that RBC has become 120 days finished? So got struck in spleen. That is, once the RBC cells mature, the immature RBC cells are called reticulocytes. They are bigger in size and they have nucleus. RBC cells doesn't have nucleus. It is by concave shape. It is a disc type, right? Where flexible, it is easily movable.
Yes.
Even in the endothelial cells, that is capillaries, there also it will move. It bends itself and moves easily. So what is happening? Once the matured RBCs are formed, that is smaller in size and more in number, which carries oxygen because of hemoglobin. Each hemoglobin carries 4 oxygen molecules. So to wherever the site oxygen is needed. यहाँ तक समझ में आ रहा है? Let me tell in Urdu also. Okay. तो जब हम RBCs को घूमने देते हैं बॉडी में, जब RBC cells has a cell membrane, उनके ऊपर एक membrane होता है. RBC cells has a membrane. तो membrane क्या होती है? वेयर एंड टेयर होना शुरू हो जाता है। जब भी वो घूमती है आरबीसी थ्रू आउट द बॉडी टेकिंग ऑक्सीजन, तो वो वेयर एंड टेयर हो जाती है, टूटने लगती है। वो टूटती 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 जब भी कैपिलरीज में जाती है, विच इज ऑलवेज उसके ऊपर के सेल्स है, जैसा अगर ब्राइडल दुल्हन जो है बड़े गवन्स में जा रही है, तो जगह छोटी है तो उसके कपड़े क्या हो जाएंगे, फट जाएंगे, राइट। व्हाइट गवन एक दुल्हन पहन के जा रही है, इतना बड़ा सा फ्रॉक दुल्हन का, तो वो जब पतली जगह से जाएगी तो उसका तो कपड़ा फटेगा क्या। तो वैसे आरबीसी सेल जब वो पतली कैपिलरीज में जा रही है तो उसके निकलते जाएंगे लेयर्स ऊपर के सेल मेम्ब्रेन, तो टूटते जाएंगे टूटते जाएंगे टूटते जाएंगे। एक वक्त ऐसे आएगा जब वो इवन स्प्लीन में भी जा रहे हो, स्प्लीन की कैपिलरीज बहुत ही बारीक होती हैं कंपेयर टू ऑल ओवर द बॉडी। जितने भी बॉडी में हमारे कैपिलरीज हैं सबसे पतले, मतलब डायमीटर इज सो स्मॉल, दैट इज ओनली इन स्प्लीन। अब क्या हो रहा है यहाँ पर, अब टूटते तो गए पूरी बॉडी में, स्प्लीन में भी आए और टूटते गए और पूरी बॉडी को गए और टूटते गए। आखिर में जब वो स्प्लीन की कैपिलरीज को बेयर नहीं कर सकते, बिकॉज वो तो और छोटी जगह हो गई, जितनी छोटी जगह हो गई उतना ही इजिली इट इज गेटिंग ब्रोकन डाउन, राइट। तो जहां पर यहाँ पर आएंगे तो उनके पूरे लेयर जो है खत्म ही हो जाएंगे, इट विल गेट रप्चर्ड ऑफ, बर्स्ट ओपन, आरबीसी सेल टूट जाएंगे, मर जाएंगे, खुल जाएंगे, और इट विल बिकम हीमोग्लोबिन, हीम एंड ग्लोबिन। तो आरबीसी के अंदर भी हीमोग्लोबिन भी अगेन ब्रोकन डाउन हो जाएगा। तो ये चीज हो रही है कहाँ, स्प्लीन में। क्यों हो रही है, बिकॉज ऑफ द साइज ऑफ कैपिलरी। इसीलिए हम इसे स्प्लीन इज अ ग्रेवयार्ड ऑफ आरबीसी। और वो कब हो रहा है, अराउंड 120 डेज इसके पूरे सेल मेम्ब्रेन के लेयर जो टूट जाए, और 120 डेज स्प्लीन उसको ट्रैप कर लेगी और पूरी तरह से ब्रोकन डाउन कर लेगी। नाउ वी केम टू नो द स्टोरी ऑफ आरबीसी सेल, हाउ इट इज गेटिंग ब्रोकन डाउन। जब ये ब्रोकन डाउन हो जाते हैं, देन द हीम पार्ट ऑफ आरबीसी will be converted into two major waste products. It's called bilirubin and biliverdin। ये दो प्रोडक्ट्स हैं जो है वेस्ट प्रोडक्ट्स, टूटने की वजह से हुए ना। यहाँ पर भी वही हुआ, यूरिया जो फॉर्म हुआ दैट इज बिकॉज ऑफ अमोनिया, वो वेस्ट प्रोडक्ट था, हमको एनर्जी चाहिए था, ग्लूकोज ले लिया, वेस्ट प्रोडक्ट को निकाल रहे हैं। वैसे ही जो है ये दोनों चीजों को हमको निकालना है, क्योंकि आरबीसी सेल बहुत ज्यादा होते हैं, ठीक है। तो अब इसको हम निकाल रहे हैं, इसको निकालने के लिए दिस विल गो टू लिवर एंड इट विल बी इन द बाइल। बाइल में जब ले जाएंगे, देन दिस इज व्हाट द कंपोजिशन ऑफ बाइल पिगमेंट्स। और ये चीज कैसे निकलेगी, when it goes to small intestine, the bile, where the bile pigments gets into feces, जो हमारा वेस्ट प्रोडक्ट है, उसमें जाके ये it will be excreted out through anus. So that is what the story of liver. कितना को समझ में आया, कितना को नहीं समझ। So then I'll go to the next one. आ गया, very good. Next, skin we have, yes, skin we have two glands, right? One is oil glands, another is sweat glands, right? Oil glands and sweat glands. So from oil glands also, we are excreting, and from sweat glands also we are excreting whatever the oil means, cholesterol, steroids, fats, those things we are releasing from sebaceous glands, that is oil glands, and sweat glands. Mainly, what we are releasing out with sweat glands here, or water soluble things. We are removing out from this. And next is lungs. Lungs, mainly what we are removing out, जो हमको नहीं चाहिए, this CO2, and then volatile substances also. Right. Example of volatile substances, anyone? Alcohol. कोई पी लिया अल्कोहल तो मालूम हो जाएगा स्मेल से, राइट? प्लस वो भी निकलता रहेगा. ठीक, that is sodium. And then from saliva, mainly we are removing from saliva is urea. यहाँ पर भी यूरिया निकलता है. यूरिया भी फेस से निकल रहा है, यहाँ पर भी निकल रहा है, स्किन से भी निकल रहा है, और सलाइवा से भी निकल रहा है. So this is what the excretory system. So with that, absorption, distribution, metabolism, and excretion we have completed. Can we start our today's class? Is it okay? Are you people comfortable? Yes. Okay. Can we have today's the fresh class that is coming to pharmacology? Today is very interesting topic. I have a topic which is called cardiovascular drugs.
This is a special of
For our audience.
yes.
So
It is a very interested of this topic
yeah.
of the cardiac arrest.
Today's topic is dedicated to drugs.
Yes.
Okay. Because I thought
But mixing of the Hindi language.
being a doctor, to understand pharmacology, basics I told, that is over. But we should have this fundamental thing. What exactly happens in blood and blood vessels, heart and blood vessels. So cardio means heart, vascular means blood vessels, and what are the different drugs which acts on these two organs. That is cardiovascular drugs. They can act directly through autonomic nervous system. These drugs on these organs, they may act directly. Okay? Okay. So directly means autonomic. Autonomic nervous system. Okay. They may act. The drugs may act via kidneys. Via kidneys, because antihypertensive drugs. I will tell you what is this. This is very important mechanism. RAS. What is RAS? Renin, angiotensin, aldosterone system. Very important. When the blood pressure is down, how it regulates itself to make the blood pressure up. So that we will see in any other class. But let me go with the pharmacology class. Okay. Then also we have autocoids. Antihistamines also changes the blood pressure, right? So autocoids also can be make changes in heart and blood vessels. And then we have hormones. Hormones also changes. Example of hormone, anyone? It's a life-saving drug. When a patient is on the bed, अब वो मर रहा है, डॉक्टर उसको कोशिश कर रहे हैं, they'll bring an injection, देखिए CPR करते हैं, तो मालूम हो जाए कि वो जिंदा रहेगा या मर जाएगा. What is that? It is a hormone. Adrenaline. It's a life-saving drug. Right? Okay, and increases the heart rate. This positive inotropic and positive chronotropic effect. So these are the different ways, either by directly or by indirectly, we can alter this heart and disease. With what drugs, how we are doing, that we will see when we go with particular class. So here the topics to be covered in cardiovascular drugs. We know what is cardiovascular system and what are cardiovascular drugs. The drugs which are acting on cardiovascular system is cardiovascular drugs. Now, what the topics which we covered here in cardiovascular system. Number one, first we will see the introduction. Introduction to cardiovascular system. We'll see the introduction part first. Then we will see hemodynamic. Hemodynamic. Yeah. Hemodynamic. Hemodynamic and electro. So we are very happy after hearing electro in pharmacology, right? Do we? We have to be because we are electro-homeopathic doctors, right?
Yes.
So electrophysiology of heart. This is the second topic which we are going to learn, and then we will learn congestive cardiac failure or heart failure. Heart failure, our third topic. Then in cardiovascular drugs, we are going to study very important here. There I will tell you about the RAS mechanism. That is anti-hypertensive drugs. As a doctor, we should know what are the different drugs which are used to make BP normal. Okay, that is, and then we will study anti-arrhythmic drugs. And before this, we will study even uh, anti-anginal drugs. Anti-anginal drugs are also called ischemia, anti-ischemic drugs. Okay. The third one is heart failure.
Again, repeat the topic, right? Not
Congestive cardiac failure or heart failure. Then anti-hypertensive drugs, and then anti-anginal drugs, and then anti-arrhythmic drugs. What is arrhythmias? Arrhythmic. Arrhythmic means with a rhythm. There is a particular rhythm. So rhythm gets changed. So if the rhythm is changed, what drugs we are using to make the heart rhythm proper? This is what different drugs we are studying. So before going to study the drugs, some physiological part we will see. Okay.
hypertensive. Right.
Is it over? अभी सब समझ में आ गया? आगे आगे समझ में आ गया थोड़ा सा these are the topics. I'll try to complete this in 2-3 classes so that CBS will be So here, the first thing, as we have seen, what is CVS in introduction. The first is introduction. So what is CVS? Cardiac muscle. So heart and blood vessels, right? That is CVS. We are studying about these. Then there is a word called automaticity. Automaticity. What is automaticity? See, heart is made up of muscles called, called cardiac muscles, mainly the myocardium, which is made up of a muscle. We have three types of muscles: skeletal muscle, smooth muscle, and cardiac muscle. So cardiac muscle is special. It is very much special. Why we say cardiac muscle is special? Because such muscle we will not find anywhere in our body. It is only in the heart. Why? Because it has automaticity. Automaticity means it does not require any push, any pressure, or any person to tell to work. It can work by itself. Self generation of impulses which makes contraction and relaxation. Pumping of blood. How it is pumping the blood? It is by its own creation, where automatically works from the birth, from the first month. That first month is not a fetus, it is an embryo. From embryo up to 2 months we call it embryo, then we call it fetus. In the embryonic stage of first 1 month, that is the 4 weeks, the heart develops and starts beating until the death of a person. So specialized. So that is the automaticity of the heart. So that means it can generate its own impulses. That is the meaning. What is automaticity? It can develop and generate its own impulses. Okay, that is automaticity. Then we will see this CDS has supplied by two types of autonomic nervous system. What are the two types of autonomic nervous system? Yeah. Then again, and parasympathetic. We will have classes of nervous system. So Dr. Zubair will take that nervous system and he will tell exactly what is sympathetic and parasympathetic. Now we will see some few points of sympathetic parasympathetic so that we can cover up here in this topic. Sympathetic means it is fight or flight mechanism. जब भी डर खौफ होता है, जब भी जगह छोड़ के भागना है, जब भी एनर्जी चाहिए, जब भी कुछ एक्स्ट्रा काम करना है, किसी को मारना है, हमको दफा चाहिए. So that energy we get when this sympathetic activity overtakes. ये दोनों parallelly चलते हैं. ये जब बढ़ जाता है तो ये कम हो जाता है, ये जब बढ़ जाता है तो ये कम हो जाता है. जब हमको इसकी जरूरत पड़ती है, कब जरूरत पड़ती है? जब हमको एनर्जी ज्यादा जरूरत पड़ेगी लड़ने के लिए. So it is sympathetic. Parasympathetic means it is called rest and digest. जब हम बैठ जाते हैं easily, coolly, calmly, आराम से पिकनिक प्लेस पे जाके सो गए, लेट गए, तो उस वक्त ये एक्टिविटी ओवरटेक्स करती है. दैट मीन्स यहाँ पर डाइजेशन हो रहा है. ठीक है, लाइक या we will just talk about it's very good for me to make correlation of this with electrohomeopathy. We have seen S1 and S2. Yes. Right? S1 is Naxonica and S2 is Lycopodium. other 8 plants are same, only this difference. So one is for hot, one another is for cold. So how this difference has come? If I see in allopathy, then I can say that what is happening exactly? It is the active constituent. What is active constituent? If you take a plant, we will have a particular constituent which makes it the action of that on our body. हमारी बॉडी में कोई एक ऐसी चीज है उस प्लांट में जो बॉडी को चेंज कर रही है, वो चीज का नाम क्या है? अगर if you see Naxomica S1, then it is strychnine and brucine. ये अल्कोलाइड्स होते हैं, और भी बहुत सारे अल्कोलाइड्स हैं. इंपॉर्टेंट अल्कोलाइड इज strychnine and brucine. ये अल्कोलाइड्स का काम क्या है? These alkaloids will act directly on nervous system. नर्वस सिस्टम में एक्ट करके उसके कंट्रोलिंग मैकेनिज्म को डिविएट कर देते, चेंज कर देते. दैट इज व्हाट. ये जो है इनका टेम्परामेंट जो है ये लोगों का बहुत ही हाई होता है स्वामी का. ओके, तो उसको क्योंकि यहाँ पर क्या कर रहे हैं, न्यूरो ट्रांसमीटर्स को इम्बैलेंस कर दे रहे हैं. दैट इज स्ट्रिचनिन. इट्स वेरी पॉइजनस. स्ट्रिचनिन एंड ब्रूसीन. अब लाइकोपोडियम में क्या हो रहा है? लाइकोपोडियम acts only on one neurotransmitter. यहाँ पर क्या है, यह आदमी उतना वो नहीं होता है, एक्टिव नहीं होता है, तो हम लाइकोपोडियम दे रहे हैं. तो यहाँ पर it will act only on one particular place where neuron has there are two neurons, right? From CNS, whatever the peripherally we get, CNS or peripheral nervous system, we know it is very easy. Brain and spinal cord, whatever the branches which are coming out, now I can feel this pressure. Why I am feeling? Because of peripheral, periphery, बाहर वाले. Other than CNS, अगर बाहर है तो वो बोलते हैं periphery. Periphery में two neurons होते हैं, whether it is sympathetic or parasympathetic. तो यहाँ पर क्या होता है, न्यूरोट्रांसमीटर एसिटाइलकोलिन रिलीज होता है इन द फर्स्ट न्यूरॉन. दोनों में भी फर्स्ट न्यूरॉन या जंक्शन जो साइनैप्स होता है, सीएनएस से बाहर निकला, ये जो साइनैप्स है, इट इज कॉल्ड साइनैप्स. देयर इज नो कनेक्शन हियर न्यूरॉन, बट द न्यूरोट्रांसमीटर व्हिच इज रिलीज्ड विल मेक दिस हैव एक्शन पोटेंशियल. So here it is always acetylcholine which is going to release. This is a neurotransmitter in the first neuron. अब दोनों में फर्क क्या हो रहा है? फर्क है सेकेंड. यहाँ पर जो है ऑर्गन है, तो ये जो जंक्शन है, दिस इज न्यूरो मस्कुलर जंक्शन. यहाँ पर क्या हो रहा है, अगर मसल की बात करेंगे और ग्लैंडुलर व्हाटएवर इट इज, तो यहाँ पर इफ इट इज अगेन acetylcholine release, then it is parasympathetic. Is it clear? Neurotransmitter release हो रहा है, वो neurotransmitter दोनों जगह सेम हो रहा है, then it is parasympathetic. Rest and digest क्या काम नहीं करेगा, उसकी छोटे चीजें काफी है. आराम करने के लिए जो चीजें चाहिए, डाइजेशन के लिए जो चाहिए, वो एसिटाइलकोलिन मेंटेन कर लेगा. ओके, और ये क्या कर रहा है, हार्ट पर एसिटाइलकोलिन डिक्रीज कर रहा है, हार्ट के इफेक्ट को डिक्रीज कर रहा है एसिटाइलकोलिन. अगर पैरासिम्पैथेटिक एक्शन हार्ट पर हो रहा है, then the action of heart decreases. It has negative inotropic and negative chronotropic effect. ठीक है. अगर इस जगह noradrenaline, it is also another neurotransmitter. So if it is noradrenaline, then it is sympathetic. Neurotransmitter is the example. Noradrenaline is the example of sympathetic nervous system. तो ये जो sympathetic activity हो रही है, ये noradrenaline से हो रही है. यहाँ पर क्या हो रहा है, हार्ट रेट और हार्ट का फंक्शन बढ़ जा रहा है. सादा हो जाएगा अगर sympathetic हो तो. Each and every organ, most probably it is increasing. Okay, पहला तो सेम है, acetylcholine only it acts. तो अब हम आएंगे हमारी पॉइंट को, that is lycopodium. तो lycopodium has lycopodium spores. The spores are the active constituent. तो वो spores जो है they will work on binding or inhibiting the anticholinesterase enzyme. Anticholinesterase enzyme. देखिए inhibitory action on cholinesterase enzyme, not anti, because I'm writing inhibitory. So inhibitory action on cholinesterase enzyme. Cholinesterase क्या होता है? For anything, हमारी बॉडी में कुछ भी हो, any change भी our body needs, वो जो है अपना एक्शन खत्म करने के बाद वो टूट जाएगा. टूटने के लिए हमारे पास एंजाइम्स हैं. That is from God. We have enzymes that converts whichever our body needs, whichever does not need, that is excreted out. जब acetylcholine release होगा either here or here, ये cholinesterase enzymes act करेंगे उस पर. The whole acetylcholine is not acting. If it is 100% releasing, only 10 or 5% will act. It will go and bind to the receptors and it elicits the pharmacological action. Most probably ये पूरे खत्म हो जाएंगे. वो होते हैं इस एंजाइम से, cholinesterase enzyme. Cholinesterase enzyme ब्रेक डाउन कर देता है acetylcholine को, choline and acetyl coenzyme A में कन्वर्ट कर देगा. तो ये है cholinesterase का एक्शन. लाइकोपोडियम क्या कर रहा है? It has inhibitory action on cholinesterase enzyme. cholinesterase enzyme का एक्शन को रोक दिया. अब cholinesterase क्या कर रहा है? acetylcholine को ब्रेक कर रहा है. जब हम cholinesterase enzyme को रोक दिए तो क्या होगा acetylcholine का? तो बढ़ जाएगा, क्योंकि वो ब्रेक डाउन नहीं हो रहा ना, it's not getting broken down. So the concentration of acetylcholine increases. As acetylcholine increases, parasympathetic activity